Algebra 1, Concept 1220, Line of Best Fit. Below is an image of a scatter plot. A scatter plot is a graph of data points showing the relationship between two variables. If you look at this scatter plot, it's talking about hours spent studying and the score on a final exam. Let's take a look and see if we can answer these questions by looking at the graph. If you study for 3 hours, what grade do you expect to get on your final? On the x-axis, go to the bottom and find 3. And if you follow that up to an ordered pair, it looks like the point is at about 60. So you could expect to get about a 60%. What about if you get a 90% on the final? How many hours might you have studied? So because it's talking about the percentage, go to the y-axis or the vertical line, go to 90. And you can see that there are 2 points. So you could say that you probably studied anywhere between 5 and 7 hours. The last question asks you what tends to happen to the score on the final the more that you study. Well, this shows that it's going up. So there must be some type of positive relationship between these two variables. So it looks like if I study more, I'm going to get a better grade on my final. Correlation. Correlation is a description of the type of relationship between two sets of data. Okay, if you look at the first example there, it says positive correlation. If we were to look at slope, we would say that's a positive slope. It's going up from left to right. It's the same thing here. As the x value is increasing, the y value is also increasing, making that a positive correlation. The next example says negative correlation. Okay, the x value is increasing, but the value of y is decreasing. It has a negative correlation. And the last example, there's really no correlation. The x value is increasing, but the y value has no pattern. So what is the correlation coefficient? This is a number that indicates the type and the strength of correlation between variables. Okay, you're going to be able to get a very accurate correlation coefficient from your calculator or computer. R has to be a value that is between -1 and +1. So you can look at some of the examples here. -1, or a correlation coefficient of -1, it looks pretty linear, so it's a pretty strong correlation between the two. Very strong negative correlation when you're at -1. And as you kind of move to the right through these different correlation coefficients, you can see that the points get a little bit more and more spread out. You can still see that they're negative, but when you get to r equals 0, or the correlation coefficient is 0, there is no correlation. There's no rhyme or reason. The points are just kind of scattered everywhere. And then as you get into the positives, the points show a little bit of a trend of positive relationship. And then when you get r equals 1, you have a very strong positive correlation between two different variables that you're working with. Let's look at some examples. Determine whether there is a correlation between the data and maybe give a possible r value. Height in inches and grade on your midterm. There is no correlation between these data. The height you are and the grade you get or earn are not correlated at all. So we would say that r equals 0 and there's no correlation between these two. Let's look at the next one. There's daily rainfall and the relationship shopping at the mall. So you can see that they've drawn a line and it tends to be going negative or down. So that means as the rain increases, the number of shoppers at the mall decreases. So we would say there's a negative correlation. I would say that the points are kind of close to the line, but they're still pretty spread out. So maybe the R value is -0.5. You could be within a little bit of wiggle room there. It doesn't have to be exactly that, but that's what we're going to go with today. Look at the next example. Hours of studying versus grade on your midterm. Again, looking at the line that they drew, it is increasing from left to right, which means the more time you spend studying, the grade on your midterm is going to increase. To us, we've talked about this before in another example, that is a positive correlation. Now, I wouldn't say R equals 1 because the points are not linear. They're not all sitting directly on that line, but I would say it's pretty close. You might say an R of 7, 0.7, or 0.8. Causation. This is when variable is directly responsible for causing the other variable to occur. Okay? You can have correlation without causation, and we're going to talk about that a little bit here. Let's look at the first graph. Fresh lemons imported to the United States from Mexico and total U.S. highway fatality rate. Okay? The number of lemons that we import has nothing to do with highway fatality rate. There is no causation. Lemons don't cause fatality rate. There is a correlation, okay? There's a strong negative correlation. It's going down from left to right. So we can have a negative correlation but no causation on the first example. On the next one, hours spent studying, score on a final exam. This one is a good example, so we keep using it over. We know that there's a positive correlation to that, but does studying cause you to do better on an exam? We believe that it does. So there's probably some causation, positive correlation, and there is some causation. If you spend time studying, you're going to do better on an exam. The last one, the number of storks that there are in relationship to the population. It looks as though there is a positive correlation, but do storks really cause the population to increase? No. As much as you want to believe, the causation is incorrect. So there is a strong positive correlation, but there is no causation in this example. A line of best fit, as you can see from a few of the examples above, is a line drawn through the middle of a scatter plot that follows the data. There should be about as many points above the line as there are below a line. And this is a line that you're just going to draw yourself. You might use a straight edge or something, but you actually create and come up with that line. A line of best fit is a line that is going to be generated by a computer or a calculator. Let's look at an example here. Plot the data given. The table seems to be written backwards, so when you see me write these, you'll notice that water consumption is on the x-axis, so I labeled y and x so that I would know how to graph these on the grid. I plotted all the points. I'm going to create a line of fit, and now it says which equation best represents the line of fit. The thing that I think is easiest is when you're choosing your line, you need to look at the slope and the y-intercept. That slope is increasing. It is positive. It's going up from left to right. So I should be able to look at my choices of A, B, C, and D, and if I have a negative slope, I'm going to eliminate those choices automatically. Same thing for my y-intercept. My y-intercept seems to be around 70, 75, somewhere in that region. If I have anything that's negative, I can probably eliminate those choices as well. So let's look at the examples, the choices here. Y equals negative 3x plus 80. I underline negative 3 because I can see right there that the slope is negative. Our slope is not negative in our scatter plot, so I can eliminate A. B, y equals 2/3 x minus 50. My slope is 2/3, that's positive, so there's a chance that could be correct, but then it says that my y-intercept is negative 50. Our y-intercept needs to be a positive value, so I can eliminate B. C has a negative slope and a negative y-intercept, so I can eliminate that. And then D has a positive slope and a positive y-intercept. So I'm going to choose D as my best answer.